Hey everybody, it's Mr. Bortnick for AP Calculus AB. We are starting Unit 3 today, which is on differentiation, composite, implicit, and inverse functions. Our first topic is topic 3.1, where we're learning the chain rule, which is a really important rule for AP Calculus. Enjoy! All right, welcome to Chapter 3. We are starting Chapter 3, which is on differentiation, composite, implicit, and inverse functions. Today's lesson is on 3.1, the chain rule, which is probably one of the most important derivative rules there is. It's frequently used in combination with all sorts of other rules, and it's one we're going to be using quite a bit of moving forward this year. I want to just sort of review where we're going. We know that back in Chapter 1 we had limits, and so that is sort of its own standalone topic. Limits sort of pops up a little bit here and there with the definition of derivative, the definition of integrals. We then have chapters 2 and 3. In chapters 2 and 3, this is mostly about derivative rules and how you take derivatives. So derivative rules and how you take them. So teaching you how to do that. And then that leads us into chapters 4 and 5 on the AP exam, which is applications of derivatives. So thinking of, if you're sitting in these lessons thinking about what do we use this stuff for? Why am I taking all these derivatives? Just keep in mind that most of those topics are in chapters 4 and 5, really thinking about what are derivatives actually useful for. But for now, we're trying to learn the basics, the fundamentals. How do you take derivatives? And we already had a chapter, all of chapter 2, where we learned quite a few rules along the way, right? We learned the product rule, we learned the quotient rule, we learned how to take derivatives of lots of trig functions. In this chapter, it says the title, right, is composites, which would be the chain rule today, implicit differentiation, which we'll be doing in the 3.2 lesson, and then inverse functions, which is 3.3 and 3.4, getting into just regular inverse functions and then inverse trig. But that's our overview of chapter 3. Let's get into today's topic, which is what's called the chain rule. So the chain rule is all about how do you take the derivative of composite functions, aka a function inside of another function. If we think back to previous years of math, our standard composite function is written as f of g of x. And we remember that in this case, the way that this is written, that g of x is the input for the f of x function. And frequently, with the way that we would think about this, is especially in calculus, is we want to think about these in terms of what we refer to as the inner and the outer function. So what function is on the outside here in our f of g of x? Our outside function is the f of x function. And inside of that f of x function is the g of x function. And so you'll notice as we go through a bunch of these, I'm frequently going to be trying to identify which function is on the outside and which function is on the inside, because that's going to help us apply this chain rule. But we've got 3 quick examples here where we just want to identify what the outside and the inside are. In this case, if I take a look, I see that x squared is inside of the parentheses for this sine of x function. So if I were to refer to my outside function as f of x, right, this is my outside function, f of x, that's going to be the sine of x function. So we can't just say like the word sine. Sine by itself is not a function, but sine of x is a function. And then our inside for this problem, which I'm going to refer to as g of x, is that x squared. Now we can always determine whether or not we picked the correct f and g of x by actually finding f of g of x. Right? If we did f of g of x for this particular problem, we would be replacing, let's get a different color here, we would be replacing this x with whatever our g of x is. And so if I were to take that x squared and put that where that, make that the input for my f of x function, we would have sine of x squared, which is exactly what we would want that function to be. So we've broken it down into our outside and our inside. What about for this next one? Our outside function f of x and our inside function g of x. Here we notice that this natural log function, ln of x, is inside of the parentheses. It's under the parentheses. So I'm going to label that as my inside function, my g of x, the natural log of x. I've seen a lot of students writing this on assignments that this is an I. This is not an I, it is an L. It's a lowercase l. It's a natural logarithm. And so it's a lowercase l of n, the natural log of x. What is our f of x function? Our f of x function is our outside. So what is this natural log inside of? Well, it's inside of the square root function. So the square root of x would be our f of x for this particular problem. And again, we can test and make sure, if I were to take this ln of x and replace it with that x there, would we have the original function? I say yes. And so that would be our outside and inside functions for this. Here, in our third one, we've sort of got three layers for this. I actually see like an outside, a middle, and an inside. There's sort of three layers to it. While these first two problems that we had over here had two layers to these composite functions, here we have cosine on the outside, sine directly inside of that, and then inside of the sine is a third function, that 5x. Sometimes we refer to these, in a couple different ways, but I'm going to treat this almost like this is f of g of h of x, where I've got these three functions here. F of x being the outermost function, so the outermost function is cosine of x. My middle function here would be sine of x. And then my innermost function, I'll call h of x here, my innermost function would just be 5x. And so what I can do here is, if I want to try to collapse these, really imagining taking that 5x, that's going to replace the x here. And so if I were to substitute that in, and then I could take the whole second expression, let's do a different color here, let's do red. If I were to take this whole second expression, replace that with this x here, we could collapse that in, and that would be equivalent to the same function. So really the only reason I'm thinking about, I want to be able to identify the different layers of these functions in order to help me use the chain rule here, because I need to know what the f of x and the g of x are for each of these. What does our chain rule actually say, though? So the rule itself is used to find the derivative of a composite function. So again, a composite function is a function where we've got a function inside of another function. And so we're saying, okay, well, the derivative of f of g of x, so f of g of x, is written as the derivative of the outside with the inside plugged in. So f prime of g of x times the derivative of the inside, so g prime of x. So if I want to take the derivative of a composite function, take the derivative of the outside, plug the inside function in, then multiply by the derivative of the inside. That is our chain rule. And again, this is one of the most important rules probably in all of Calculus 1, because we use this in combination with a lot of our different rules from Chapter 2. We can do the product rule and the chain rule together. We can do the quotient rule and the chain rule together. We can do trig functions with the chain rule. Any rule that we've learned so far, we can essentially use that in a composite situation with the chain rule, which is really nice because it expands our ability to take derivatives significantly. Let's talk about number one. So we want to find the derivative. At least for these first couple of ones, as you are working through these and getting practice, like everything else in math, the only way that we get better is through practice. And so I encourage you to, take these notes and to go and try some practice problems and really get used to doing this process. As you're doing this, my suggestion would be to identify that outside and the inside. So my outside, I'm going to call f of x. My inside, I'm going to call g of x. And so here is how I would set this up, at least for the first couple times that you are doing it. So what's the inside? Well, we noticed we've got this parentheses here, and that x squared minus 5 is our inside function. So that is x squared minus 5 is inside of those parentheses. But what is the function on the outside? If we sort of imagine here, we've taken this part, we have this inside part, which is being raised to the fourth power. So something is being raised to the fourth power. So our outside function is actually x to the fourth. So x to the fourth would be our outside. Our inside is x squared minus 5. While we're doing the setup here and this sort of getting ready to do the work, I'm going to take the derivatives of each of these. f prime of x, the derivative of x to the fourth, is going to be 4x cubed. That's our regular power rule from chapter 2. And g prime of x, the derivative of x squared minus 5, is going to be 2x, using that power rule from chapter 2. So this is my side work. Now again, from our chain rule up here, if we're going to take the derivative of the composite, it's going to equal f prime of g of x times g prime of x. So I'm going to get that set up over here. Let's change the color. So our derivative is going to be f prime of g of x times g prime of x. All right, what does that look like for this particular problem? Well, f prime was 4x cubed. So 4, and instead of our x, right, we're going to substitute. We notice that g of x is the input for that f prime. So if I look at that f prime function right here, where that x is, we're going to substitute in the whole g of x equation. So instead of x for that 4x cubed, we're going to have an x squared minus 5. Actually, let's do it with a different color. So we substituted x squared minus 5 in for that function, and then that's being raised to the third power. So this is f prime of g of x, and then we still need to multiply g prime of x. So times g prime of x was 2x. And so this expression would represent the derivative for f of x. We're going to probably call that, f prime. It's going to be useful. We want to be careful, we don't want to mix that obviously up with the f prime that we have up here. This again is sort of like side work that we've got, but we're taking the derivative of our original function, which using that chain rule is 4 times x squared minus 5 to the third power times 2x. I'm going to clean it up a little bit. We'll multiply that 4 and that 2 together, so that is going to be 8x times the x squared minus 5 to the third power. I think that is probably a good spot to end for this particular problem. Nice. That's number 1. Number 2, let's do the same process again. I'm showing again what this side work looks like. I'm going to find my outside. I'm going to find my inside. My outside I call f of x. My inside I call g of x. The inside of our parentheses here, or of our square root here, is that 4x minus 3. So that is the inside. Well, what is that inside of? Well, it's inside of this square root function. And so our outside here is going to be the square root of x. And we know that that's the same thing as x to the 1/2 from chapter 2. But, let's take the derivatives of each of these. So we learned back in chapter 2 that the derivative of the square root function, if we want to rewrite that as x to the 1/2, that the derivative is going to be 1 over 2 square root of x. And again, you could rewrite that as x to the 1/2 and then use your power rule and then simplify, but you'll get 1 over 2 square root of x. And by our power rule, the derivative of 4x minus 3 is just 4. Okay, so that's our side work. Let's take a look. So again, we're going to do the f prime of g of x times g prime of x. F prime is going to be this 1 over 2 square root of x. So 1 over 2 square root of, again, the input for f prime of x function needs to be g of x. So instead of the x right here, I'm going to plug in the whole g of x function, which is 4x minus 3. So this is the square root of 4, and actually let's be consistent with our colors. We were using that for our g of x before, so 4x minus 3 got substituted in as the input for that f prime of x function. And then we're going to multiply that by g prime of x, so times g prime of x, which is 4. So if we want to simplify, that's going to be 4 over 2 square root of 4x minus 3. And if we simplify further, that is 2 divided by the square root of 4x minus 3. That is our derivative function for g of x, which, we should call g prime for that. That's going to be number 2. Number 3. Ooh, this one looks like a 3-layer one. 3 layers to it. How would I rewrite this? I want to just sort of remind you that when we have this squared on the sign, that means it's the whole expression being squared. And the reason why we write it on the sign is so that we don't confuse that with like the x being squared or the 5x being squared. It is representing this whole thing. And so a different way that we could write this is that this is like sine of 5x quantity squared. And so that is an alternative way of writing that. But frequently, in higher level math, we put the squared on the trig function to represent that it's the whole thing squared, because it's confusing if I have it right here, because we don't know, is it the whole thing, or is it just this part, or is it just the x? So that's the standard of how that's normally written. But if you know to rewrite it like this, then it's a little bit easier to see those layers maybe. Specifically, we see that there is an outside function, this part is being squared. Then inside of that, there's a sine function. And then all the way on the inside that there's this 5x. And so if we want to write this, I'm going to say outside, middle, inside, using that same terminology from before. But f of x would be still our outside function. So f of x is the outermost function. That's going to be something being squared, so x squared. G of x is our middle function. And so that is sine of something. And then h of x is our innermost function in this case because there's 3 layers, and we'll call that 5x. If I take the derivatives of each of these 3, the derivative of sine of x, we'll call that f prime, that is 2x. The derivative of sine of x, we know, is cosine of x. And the derivative of h of x is h prime, which we are going to say is 5. So now that we've got that side work done, we can't just use our regular chain rule here because this is what we do for 2 layers. Here, we're going to really think about how the chain rule is set up and try to apply it here with these 3 layers. What we notice when we do this is it's the derivative of the outside first. So the derivative of this outside part is 2x. But instead of the x, we're going to leave the inside alone, right? The inside does not change. It still stays g of x. And so I'm going to make this 2 times sine of 5x. But with the way the chain rule is set up, after we write that expression, we need to multiply by the derivative of whatever the inside is. So I need to take the derivative of sine of 5x. Well, the derivative of sine is cosine, so that's times cosine of 5x. And similarly, we need to now multiply by the derivative of the inside of this 5x, which is 5. So this is interesting because, and sort of leads to why this is called the chain rule. We can use this for really a lot of different layers if we need to, by just continuing to take the derivative of the inside and multiply by the derivative of that inside going forward. Notice, we started with the derivative of x squared. That's how we got this 2, so essentially 2x, right? If we treat this like this is an x. Then we took the derivative of sine of 5x. That gave us cosine of 5x. Then we took the derivative of just 5x. That gave us the 5. So essentially, I'm just taking the derivative of the inside part each time until I have no more insides left. This is just by itself, so I don't need to take the derivative any further. How would I simplify this? I would just multiply that 2 and that 5 together. So let's do that and get our final answer here, which looks like it's going to be 10 sine of 5x times cosine of 5x. That's going to be our answer for problem number 3. Nice, chain rule. All right, we're going to show natural log 2 different ways. So the natural log of x cubed. First way is our regular chain rule. So first way is our regular chain rule. So in this case, our outside function is the natural log of x. Let's call that f of x. That's the natural log of x. Our inside function is g of x. That is going to be x cubed. If we think about our derivative rules from chapter 2, the derivative of the natural log is 1 over x, and the derivative of x cubed by the power rule is going to be 3x squared. All right, we got that side work out of the way. If we apply our chain rule for this, so it's the derivative of the outside with the inside plugged in, so 1 over x cubed, right? That's being plugged into that x, times the derivative of the inside, so times 3x squared. And that's going to simplify and be what? 3x squared divided by x cubed, or 3 over x as our derivative function for number 4. Number 5 is the exact same problem, but I want to remind you, similar to when we set up the power rule back in chapter 2, a lot of these problems, if you can rewrite them a different way, will be much simpler. I don't have to necessarily use the chain rule. The chain rule, obviously works and is fine here, but, what is this? It's a natural logarithm, which we might remember that there are some log rules. Specifically, there's a rule that says that if you have log base b of x raised to the a power, so going back to those log rules from algebra 2 or pre-calculus, that this is equal to a times log base b of x. Essentially, the rule says that we can take that exponent and bring it outside, that it comes outside and can become a coefficient of that logarithm. And this, works for logs of any base, but also works for natural logs, which are technically logs of base e, right? If we don't remember what a ln is, the natural log of x is the same thing as log base e of x. So because of that, this rule actually applies for natural logs as well. So using that property, we can actually rewrite this as 3 times the natural log of x using that property, which is super nice. And then if I take the derivative, y prime is going to be 3 times the derivative of the natural log of x, which is 1 over x, aka 3 over x. So if I remember my properties from Algebra 2 and pre-calculus, we don't even need to use the chain rule for this. We get the same answer, but, using that sort of shortcut and knowing what the natural log is and knowing our properties of logarithms allows us to make this a much faster and shorter problem. Nice. All right, number 6. This one is a little bit of a beast. We've got, clearly a composite function. A function is being raised to the third. So a function inside of a function. Why is this tough? Well, that inside function, is actually 2 things being divided, which means we need to think back to chapter 2, the quotient rule, in order to take the derivative of that inside part. Let's do it. So same as what we did before, I'm going to identify the outside and the inside. My outside function is going to be f of x, that is being x raised to the third power. My inside function is all of that stuff inside the parentheses. So t squared plus 1 divided by 2t minus 5. That's the whole inside. And I guess technically, we would want to make sure that these are, if we're going to be really clear, this should be a t, this should be a t, this should be a t. We would want all those to be t's to match the function. Or at least for the g of x piece has to be a t. It's probably okay if those are x's. Let's take the derivatives though. So f prime of x is equal to 3x squared. G prime of x, we have to do our quotient rule here. And so remember, that is our low d high minus high d low all over low squared. So our quotient rule, the way that I remember it from way back when in chapter 2, low d high minus high d low all over low squared. Okay, so what's our low? So 2t minus 5 times the derivative of the top part, so 2t, minus high, so t squared plus 1, times the derivative of the low part, which is just 2. And that is being divided by low squared, so 2t minus 5 quantity squared. All right, so here's our side work. We've got all of this as our side work. Let's get into the actual chain rule piece. Again, our chain rule here says that we do f prime of g of x times g prime of x. So f prime of g of x is going to be 3 times t squared plus 1 divided by 2t minus 5 all squared. So that, again, is our f prime of g of x right here. Right, we substituted g of x in for that f prime. That's where went in where the x was. And then we're multiplying times g prime of x. So times all of this, which I guess, maybe we want to expand a little bit. Let's take a look at that numerator. I'll just do this as side work over here. That numerator looks like that's going to be 4t squared minus 10t. And then we've got a minus 2t squared minus 2. And so that's going to simplify to be 2t squared minus 10t minus 2. So that's what our numerator is, 2t squared minus 10t minus 2. And the denominator I'll leave the same, 2t minus 5 quantity squared. We could simplify this a couple of different ways, but again, if this were a free response section on the AP exam and they asked and you need to do the chain rule, this is a totally acceptable place to stop on the free response section. However, it is probably unlikely on the multiple choice that they wouldn't simplify this, at least a little bit. We notice here maybe we could factor a 2 out of each of these terms. So I'm going to do that. And we also notice that these denominators are the same, so we can combine those in that way. How would I simplify this? Let's say this is probably like 6 times, so the 6 comes from 3 times the factor of 2 that I pulled out of each of those, times 2t squared plus 1 quantity squared, times t squared minus 5t minus 1, all divided by, well, we've got this 2t minus 5 being squared, and that's multiplying 2t minus 5, which is also being squared, so that is going to be 2t minus 5 to the 4th power. This t squared minus 5t minus 1 came from what was left over after I factored that 2 out and multiplied that 2 with that 3 to get this 6. So this is probably an expression we might find on multiple choice. There's a couple of different ways we could simplify it, maybe even further if we needed to, but I'd say that's probably a fair place to stop for this one. All right, that's number 6. On to number 7. If g of x is equal to 2x times the square root of 1 minus x, find g prime of negative 3. All right, well, immediately I noticed two things. First off is I noticed that this 1 minus x is inside of that square root. So the fact that I've got an inside here is going to tell me that I need the chain rule for this problem. But I also see that this is 2x times the square root of 1 minus x. Those are two different functions, which is telling me that I'm going to actually need the product rule here for this one as well. We said earlier that we can do the chain rule with these other ones, so this is a good example that has both the product rule and the chain rule. Now I'm going to set up first with the product rule because, overall it's a function times a function. So if I do my product rule here, the derivative of 2x, we're going to just call this whole derivative g prime of x. The derivative of 2x is 2. And if we multiply that by the original second function, that's the square root of 1 minus x, plus, because our product rule is f prime times g plus g prime times f. So plus our 2x times the derivative of the square root of 1 minus x. So what I'm going to multiply here is the derivative of this. Our outside function is going to be the x to the 1/2 power, or the square root of x. So this is going to be times 1 over 2 square root of 1 minus x. So that is our derivative of the outside with the inside plugged in. And then I need to multiply by the derivative of the inside. The derivative of 1 minus x is just negative 1. And so that is going to be our derivative function for this problem. But number 7 didn't ask us just to take the derivative. They asked us here to take the derivative when x equals negative 3. So now that we've taken the derivative and we've got this function, I would suggest plugging in that negative 3 before simplifying and see what we get. So g prime of negative 3 is equal to 2 times the square root of 1 minus negative 3 plus 2 times negative 3 times 1 over 2 times the square root of 1 minus negative 3 times that negative 1. So this is 2 times, looks like the square root of 4, so 2 times 2 plus negative 6 times 1 over 2 times the square root of 4, so 1 over 2 times 2, that's going to be 1 over 4 times that negative 1. So I have 2 times 2, which is 4. That negative 6 times that negative 1 is positive 6, so that's plus 6 over 4. So 4 plus 3 over 2, that's going to be 11 over 2 as our answer for problem number 7. Excellent. Same as what we said in the last chapter with product rule and quotient rule, a very common way that the AP exam tests to see whether you understand these rules and whether you can apply them even without functions is by using tables. So a frequent thing that they'll do is they give you a table of a couple of values or a multiple choice problem that's got a couple of values given, and then you've got to figure out how to take the derivative using that chain rule. In this case, if we take the derivative, our f prime here using that chain rule is going to be 2 times g of x. And then since g of x was the inside, we need to multiply by the derivative of g of x, so times g prime of x. This would be our derivative function for f prime if we use the chain rule on it. And so we want to know, they're asking us when at f prime of 4 for each of these. That's what they're asking us for. So f prime of 4 is equal to 2 times whatever g of 4 is times whatever g prime of 4 is. So looking at that table, g of 4, if we take a look, that looks like that's 3. So 2 times 3. And then g prime of 4, if we look at that table, g prime of 4 is negative 2. So times negative 2. So that looks like our answer here is going to be negative 12 for the derivative of f when x is equal to 4. Again, super cool that they can test your knowledge of the chain rule and your ability to apply the chain rule even when they didn't tell you what the functions were. We don't know what f of x is, we don't know what g of x is, we don't know what h of x is. Pretty crazy. All right, f of x. For our second one, we've got the square root of h of x. In this case, our outside function is the square root, so our derivative is going to be 1 over 2 times the square root of that h of x. But again, we need to also multiply by the derivative of the inside if we're doing that chain rule, so times h prime of x. All right, we're going to do the same thing with our 4's. So f prime of 4 is equal to 1 over 2 times the square root of h of 4 times h prime of 4. What is h of 4? H of 4 looks like it's 9. So this is going to be 1 over 2 times the square root of 9, which is 3. And then h prime of 4, if we take a look, looks like that's 5. So times 5. So this is going to be 5 over 2 times 3, which is 6. That's going to be our answer for our second to last problem. And our final problem, h of g of x. This is perfectly set up for the chain rule, except they don't have f on the outside. So what's this going to be? Well, it's going to be the derivative of the outside, so h prime of g of x, times the derivative of the inside, so g prime of x is going to be for that one. So f prime of 4, we're going to plug in 4 for all of those x's. So h prime of g of 4 times g prime of 4, and that's going to be what? H prime g of 4 is 3, so h prime of 3 times g prime of 4, which is negative 2. And then notice, that g of 4 was inside of this h prime, so now we need to find h prime of 3. That's actually why they gave us this row with a 3 on it. We haven't used it yet, but h prime of 3 appears to be negative 3. So this is going to be negative 3 times negative 2, which is our final answer of 6. That's it for our practice for this one, or for our notes for this one. You've got a bunch of practice problems after this to try, and as usual, I've posted the solutions as well. I would try those out. Really focus for this lesson on identifying what your f of x and what your g of x are so that you can apply the chain rule well. This is a lesson that is well worth practicing, so I encourage you to make sure that you're getting that done this week. Have a great rest of your day. Good luck, and do that mastery check. Take care.